Hi everyone, this is lesson 821 on angles of polygons. All right, so up until this point, we've mainly been focusing on triangles. We've learned a lot about triangles earlier in our book. We just recently learned a lot more about quadrilaterals and more details about quadrilaterals. So we've talked about three-sided shapes. We've talked about four-sided shapes. And the next step would be to talk about 5, then 6, 7, 8. And so instead of us just focusing on one of those, we're going to expand it to all polygons. And so this is where we're going to review a little bit about hopefully some knowledge you have from before on polygons. And then we'll go into learning a lot more about the shapes, specifically their angles, interior and exterior angles. So it kind of ties back to some stuff we did earlier in the year when we talked about angle relationships. So we're kind of, everything's kind of coming full circle, everything's tying in together. So some kind of definitions you need to know, some terms you need to know. Polygon, we have this term polygon. A lot of times a lot of students like, oh, do you know what a polygon or how many sides does a polygon have? And usually the most common answer is they'll say it has 5 sides, because usually they're thinking of a pentagon, because it also starts with a P. But polygon, poly is a prefix that means many, and gon, the ending gon, actually means angles. So the name itself kind of tells us it's a shape with many angles, but with many angles comes many sides. So an informal definition, and similar to the one that's given in the book, is polygon is a closed shape with 3 or more sides, right? So most of us like to think in terms of sides and not angles. So we're going to start with 3 or more sides. So a triangle is considered a polygon. A quadrilateral is considered, all quadrilaterals are considered polygons. So before we went over this in our umbrella of quadrilaterals, well, polygon is a bigger umbrella for all of those shapes, triangles, quadrilaterals, and beyond. So more specifically, we're going to be talking a lot more about regular polygons. And so we need to understand what this word regular means in its association with the polygon. So with a triangle, we've already been talking about a regular triangle before, and we call it an equilateral triangle. So, and it also has a second name as equiangular triangle, which means not only are all sides the same, but all angles are the same. Well, regular is pretty much one word that describes both of those, equilateral and equiangular. So equilateral means equal sides, lateral means sides, and equiangular means equal angles. Right? So when you bring both of those together, you end up with a regular shape. And so in this case, we're talking about polygons. And so here's an example of a regular polygon. You'll notice we have all the interior angles are the same, they're congruent. And you could tell by the little markings, the little tick marks. And all the sides have the same marking as well, all the same tick marks. That means all the sides have the same measurement. So if I say this measurement is 5, then all these would be 5. Right? And so if I know one of those angle measurements, then that means I know all of them. All right, so that's kind of the basics of what we need to know moving forward. In addition to understanding really what a polygon is, it helps if we know some of the names of polygons. Some of these you might be familiar with. So we started with a polygon with 3 sides is a triangle, which we're all familiar with. 4 sides, quadrilateral, we just spent a lot of time with. 5 sides is a pentagon. 6 is a hexagon. 7 is a heptagon. I hope I got that one right. I didn't look it up. 8 is an octagon. Traditionally, we'll see an octagon with a stop sign. Right? Stop sign usually has 8 sides. Or maybe someone's fighting in an octagon. Nonagon. Here's one that's maybe not so common. For 9 sides is a nonagon. 10 sides, hopefully you're familiar with that. Decagon, kind of like 10 years is a decade. Or we measure things using the decimal system, right? So, which goes by tens. And so that's something that's you should be familiar with. The next two, usually the first up to 10 is usually the ones you need to know names for. Beyond that, it's kind of I don't want to say optional, but it's not common that you might see like an 11-sided shape. And so there's a couple names for 11-sided. One name is the undecagon, and 12-sided is common for us, and that's a dodecagon. And so just a little bit background on those names is, or at least a way to remember this. So decagon, right, means it has 10 sides, and the prefix, if you know anything about Latin or Spanish, if you look at the word uno, means 1. All right, so if you look at that prefix un, that's 1, and 10 gives us 11. And so the same with dodecagon. This do, if you look at the Spanish or Latin word, dos means 2. All right, so this is the same as 2. Right, uno is equal to 1. So 1 plus 10 is 11, or 2 plus 10 is 12. All right, so those are names, common names. If you don't happen to remember the name of a shape, like an 11gon, or undecagon, dodecagon, or maybe 13 sides, like, right, there's 13, 14, there's like an infinite number of sides. There's not going to be a name for everything. And so one way of naming polygons is by just using the actual number. So sometimes we'll call it an 11gon or a 12gon. There's a lot of names. If you go to 100, this one has the name of a hectagon, but most people won't remember that. It's a lot easier just to use 100gon, right? Or maybe like a 98gon, right? There's not going to have a special name. So when you come to some n sides, right? N represents some number of sides. We don't know what that number is. We would call it an n-gon, right? So n could be any number, right? In this case, n could be 23. So this would be a 23gon. All right. So let's go on. That's a little bit of background that I feel you need to have. Definitely, hopefully you have that in your notes. Copy down those names. They will come up in certain problems. They might ask you to find the angles of a hexagon, and you need to know how many sides that has, or decagon, right? Something like that. Those are common shapes. All right, so we're going to develop a couple of shortcuts or formulas. Oops, getting ahead of myself. Let me redo this one. All right, so this is a handout. I'm going to try, I might post this handout for you to use if anyone feels it useful to have in your notes. Otherwise, you should be fine with either maybe copying down just some of these shapes. There's going to be a total of 6. So even if you have maybe half of these, you should be fine if you're just going to copy these into your notes. I'm also going to be filling in a table at the bottom. All right. And so what we're going to try to figure out here is the interior angle sum of polygons. Means what do all the angles in the inside of these polygons add up to? Well, we've already done this, and this first shape, the first one says n equals 3, which means it has 3 sides. So as we could see, we have a triangle. Right? What do all the angles of a triangle add up to? Right? You should know the answer to that. Okay, so if you said 180, you would be correct, right? So this is 180 degrees if you add up all 3 of those angles. All right, now that's pretty easy. I'm going to put some other notation here. We have one triangle. Now with a 4-sided shape, we haven't really talked too much about quadrilaterals like this, but what do all the angles in a quadrilateral add up to? Well, now there's 4 angles. Now you could take a guess, right? You could take a guess and say, well, maybe it's still 180. Now there's 4 of them. Or maybe, I don't know. I don't know what your guess might be for this. So what I'm going to go over is a strategy to help us figure out what do all those angles add up to. And so the strategy really is to focus on what we do know, and that is a triangle. So if only I could change this picture, this quadrilateral, into triangles. So what I'm going to do is I'm going to start with, I'm going to pick a point, one of the vertices, and what I'm going to do is I'm going to draw in a line segment from this point to all the other vertices. So if I draw a line to here, well, that line's already there. I don't need to draw that one. If I draw a line to here, this endpoint, that line's already there, so I don't need to draw that one. But this point, I do need to draw that one. And so I'm going to draw a line from here to here. And so when I do that, what it does is it splits this quadrilateral into 2 triangles. And as you could see, I haven't disrupted the angle, right? So, but what I do know is these 3 angles, right? These 3 angles on the top triangle should add up to 180. And then the ones at the bottom, right, the rest of that angle, these 3 should add up to 180. All right, so that's 180 and 180. Oops, 180. So we had a total of 2 triangles. All right, and so I'm going to repeat this process for all these. And so let's see. I want to see how many triangles I'm going to have if I draw in diagonals here. Now, let's see if I could do this. I'm going to draw a line here, right? And I want to make sure I'm not intersecting any lines. I'm picking one point because I want all my lines to come out from that one point. Kind of like it's the sun and here's the rays. All right. So at this point, I can't really draw any other lines. If I start drawing lines like this, then I'm crossing. That doesn't make any sense. So they all have to start from one point. There are other approaches to this. This is the easiest. And so how many triangles do I have? All right, so it looks like I have 3 triangles. right? Where each one of these is going to be 180. Right, so these angles, right? Every angle is accounted for. Every angle is accounted for. I don't have extra angles. So when I look at this angle here, it's counted in all three pieces. All right, same thing with the other two pieces here and there. All right, so if I continue this process for the rest of these, what do you think? Can we do this without drawing the lines? All right. Can you tell me how many triangles? See, if this was, we had 3 sides and we had 1 triangle. We have 4 sides and we have 2 triangles. We have 5 sides and we have 3 triangles. With 6 sides, how many triangles do you think we should have? All right, if you said 4, you'd be correct. And so this would, I'll just do this one real quick. So I'm going to pick a point. I'm going to draw in my lines. Oops, I could draw that one better. Something like that. So there's my 4, 1, 2, 3, 4 triangles, each one equal to 180 degrees. All right, so this continues. How many, if I have n sides, I should have 5 triangles. If I have 8 sides, I should have 6 triangles. All right, so whether we draw them in or not, we already know how many triangles there are, right? So do we need to draw those in? That's really the question. So if I want to know what all these angles add up to, well, one, I could just add up the 180 degrees. So here I have 180 for a triangle. 180 plus 180, that gives us 360 for a quadrilateral. And then I have 3 of them for this pentagon, right? And I have 4 of them for this hexagon, and it continues. All right, so let's organize this information in a table. So this is kind of what we're building up to. So I'll leave it like that. All right, so when we had 3 sides, the sum of the interior angles was 180 degrees. With a 4-sided, we said it was 360 degrees. And for 5 sides, what is it for 5 sides? So remember, we had, so there was triangle equals to 1, triangle was equal to 2, to 3, to 4, 5, 6. Right, those are the number of triangles. So if we have 1 triangle times 180, it's 180. 2 triangles times 180 is 360. 3 triangles times 180, what does that give us? I think that is 540. And then we have 4 triangles times 180. What is that? 720 degrees. And then 5, this is going to be 900. And then 6 triangles for the 8 side of the octagon is going to be 1080. Right? Should recognize that number, 1080, maybe for some TVs, your resolution. All right, you'll notice 100, we do not have a picture for 100. Should we draw it? Do we need to draw it? So the question I'm going to ask you is, how many triangles is a hundredgon going to have? All right, if you said 98, you'd be correct, right? How did we get 98? Well, for all of these, this number was always 2 less than the number of sides. So 3 minus 2 is 1. 4 minus 2, 5 minus 2 is 3. 6 minus 2 is 4. 8 minus 2 is 6. 100 minus 2 is 98. All right. So, and then how do we figure out what all those angles add up to? Right? No way we're going to draw a picture for that. So on this previous one, just as a reminder, if we took our 8 and we subtracted 6, that gave us the number of triangles, right? But we needed to multiply that by 180 so that we could get the total angle measurements. So this was 180 times, oops, my bad, 8 minus 2, sorry, my mistake. 8 minus 2 is 6, and if you multiply 180 times 6, then that gives you your 1080. All right, so if we're going to do 100, then we could do 180 times 100 minus 2, right, which we said was 98, right, 98. And so what is 180 times 98? What did I say? 180 times 98. All right, so this is going to be 17,640 degrees. Right, there's no way we would have been able to draw a picture that big and added up all those measurements. All right, so for the n-gon, the number of triangles is going to be n minus 2. That's the number of triangles. And so our little formula, I'm going to zoom into this. So our formula that goes here is going to be 180 times n minus 2, right? 180 times the number of triangles, which was n minus 2. Don't forget that n represents the number of sides. N minus 2 is the number of triangles. All right, so this is what we call, or this is how we calculate the sum of the interior angles. All right, so now we have a little formula we could use. We don't really need a picture, we just need to know how many sides there are. So if we know how many sides there are, we could very easily calculate the sum of the interior angles. All right, so as we continue, all right, so here, it's nice when we know what they all add up to, but what if we don't want to know what all of them are? We just want to know what one of the angles is. All right, so here we're looking at a regular polygon. Specifically, we're looking at a regular hexagon. And what we want to know is, what is one of these angles equal to? Right? It's nice. We could probably figure out all of them together, but what if I just want to know one of them? Okay, well, we have to start with what we know. And first, we look at the name or the picture, tell us some information, and that is that the number of sides is equal to 6. All right. We also know that the sum of the angles is going to be 180 times n minus 2. So we just learned a formula for this. So let's start with finding out what they all equal to. And so the sum of the angles is going to be all these x's. So if you notice, there's going to be a total of 6 x's that make up the interior. So if I add all those together, they should equal to the result of this little formula we just created. So 180 times 6, because I'm using this 6 as the number of sides, minus 2. All right. So at this point, we're just simplifying it. So when we add up all those 6's, we end up with 6x. The next step is to figure out what x is. So we're going to divide both sides by 6. And we're going to be left with x equals to 180 times 6 minus 2 divided by 6. All right, so this is kind of the first part. I didn't do the subtraction yet because I want you to see the answer in this form. We just figured out what the interior angle equals to. So we know that all we have to do is simplify this. So I'm going to take, let's take this. And so x equals to 180, and 6 minus 2 is 4, divided by 6, and x equals to, so you have choices. You could try typing all that into the calculator, or maybe you could try to simplify it. 180 times 4, or maybe you want to do 180 divided by 6. I'm not going to tell you how to simplify that. I'm going to let you choose what approach works best for you. But I would probably reduce 180 divided by 6 first, which would be 30. And then 30 times 4, that I know is 120. So figure out what you could do that's easier for you. All right, so now we know this angle up here is 120 degrees. All right, so let's try this with another shape. If I give you a regular octagon, and again, notice there's no markings on here, there's no even letters here, but we're told the name of the shape is regular octagon. All right, so regular already tells us all these sides are the same without them giving us the tick marks. And it also tells us that all these interior angles are the same. All right, so the name octagon tells us we have 8 sides. And if we want to know the interior angle, right, kind of like before, I've started this for us. We're going to take the total of all the angles, which is 180 times 8 minus 2. That's the formula we just developed. And then we're going to divide by what number, right? So I'm trying to help us skip all that work that we were just finished doing on part A. In the end, what number can I put here? Right? Look at what we have here. Right? So 180 times 6 minus 2 divided by 6. So that means really what I could do is just divide this by 8. And now I just have to simplify it. Right? There's our formula that we could use. So let's simplify that. And let me use, all right, so interior angle, or you could tell me what this equals to. Reduce that, see if you could do those calculations and tell me what that equals to. All right. And so hopefully you got 135 degrees. Okay, and that would be our answer. All right. And so here's, now that you're kind of a little bit more familiar with this, what we're looking to do is really utilize this formula we just came up with. And so interior angle is equal to 180 times n minus 2, which is the total, divided by the number of sides. All right, so there's our kind of our little formula that you should know. And let's see if you could calculate these. So regular nonagon and a hundredgon. All right, I'm going to work these out, but I'm going to ask you first to do it. So you let me know what the interior angle is for each of these. All right, so let's see if you got these correct. So nonagon was how many sides? This should be n equals to 9. And then the hundredgon, that's going to be n equals to 100. That's what we're starting with. We already have a formula, which we've said is interior angle. I'm going to just put int angle is equal to 180 times 9 minus 2 over 9. And then I'll do the other one as well. Interior angle is equal to 180 times 100 minus 2 over 100. All right. So that's how we set up both of these. And then you could simplify it. Hopefully you could do at least the subtraction of 2. That would probably be the first step. So 100, we already did that one, 98, 100. All right. And so then we would just have to type those into the calculator, or maybe you know how to reduce this. 180 divided by 9, that's 20. I know that one, which means this is 140 degrees. All right, hopefully you got that correct. So interior angle is 140 degrees. And then this one, definitely I would have to put that in a calculator. So let me do that. So that's 180 times 98 divided by 100. All right, so we get 176.4 degrees. All right, so there's our interior angle. All right, this is a type of question you will be expected to answer. Very straightforward. If I give you a shape, can you tell me what the interior angle is equal to? All right, in addition to that, we have an exterior angle to go along with our interior angle. And as you could imagine, exterior means it's on the outside. Right, so I've kind of already started this for us. So here we have a regular hexagon that's given to us. I didn't write it down, but yes, this is a regular hexagon. And if we look at this shape, we see there's an angle labeled on the outside, right? So why is there an outside shape? Well, usually we just have the hexagon, but we've extended these lines. If you extend the lines, then it forms angles on the outside. And so some things that we notice is that all the exterior angles are congruent. And all the exterior angles are also supplementary to the interior angles. Okay, so let me explain that. So we already know about interior angles. So if I look at the interior angles, we already know this is, since this is a regular polygon or hexagon, that all these angles are the same measurement. That's what we do know. And so from, I think this was earlier in the year, we talked about supplementary angles. If I have a line and I have two angles that complete that line, like a linear pair, then they are supplementary. They add up to 180 degrees. So that means that these two angles, the outside angle and the inside angle, should add up to 180. Which is why I have interior plus exterior equals to 180. Well, if all these interior are the same, then that must also mean that these angles on the outside must also be the same. So if I know one of these angles, then that must mean that I know the others. All right, so we want to know what A equals to. Well, if we could figure out what the inside angle equals to, then it should be easy for us to figure out what the outside angle equals to. So that's what we're going to do now. So n equals 2, we want to know how many sides there are. So in this case, there are 6. And we know a formula to calculate the interior angle, which is 180 times n minus 2 over n. So now that we know what n is equal to, we just have to plug in our 6. And then we could simplify this. All right, so let's do that. So we're going to be left with 180 times 4 divided by 6. And this is going to equal 2, and I think we did this earlier, this is 120 degrees. All right, so what we just calculated was the interior angle. But we want to know what the exterior angle is. All right, so that's where we're going to use this formula here. Interior plus exterior equals 180. So now I know this is 120 degrees plus the exterior should equal to 180. So that must mean, if we do some calculations here, if we subtract 120 from both sides, we're left with an exterior angle is equal to 60 degrees. All right, so we just figured out our exterior angle is 60 degrees. And our interior angle was 120 degrees. All right, makes sense. They add up to 180. All right, so that is what you need to be able to do. All right, so second or last part to this, almost done, is what if I want to know what all the exterior angles add up to? So we've already talked about adding up all the interior angles, but what happens if we add up all the exterior angles? So if let me take this shape, put it back down here. All right, so if we look again at this shape, we want to know what all those angles add up to. We just calculated that this angle on the outside was 60 degrees. So the question is, what do all of them add up to? So that means we're going to have, that's the same as, oops, I guess let me label this. So all these would be the same as A. So that's the same as having 6 A's right, equals to, so the sum of exterior. So sum of the exterior equals to 6 times A here, right? Or A plus A plus A plus A. Well, we already know what A is equal to. So sum of exterior is going to equal to 6 times 60, which equals to 360 degrees. All right, which is pretty easy. All we had to do was multiply times 6. Now, what if it's a different shape? And so what I want to do, try to do really quick. I know this is lesson's already long, but I think this is kind of key, is what if it wasn't a hexagon? What if it was a different shape? What would the sum of the exterior angles equal to then? So I'm going to do this, try to do this really quick with another shape. And let's just use, okay. So I wish it was a nicer looking triangle. All right, that's better. All right, so if I take this triangle, resize it, and I extend those lines like I did before, right? So if I extend that line and extend this line and extend this line, now I've created these exterior angles. So the question is, what do all three of those angles add up to? So we would need to figure out what the interior angle is equal to. Now this is a equilateral triangle, and if you remember anything from an equilateral triangle, all the angles on the inside are 60 degrees. So then what does the outside angle equal to? Right? Those have to be supplementary, right? They have to add up to 180, which means this is going to be 120 degrees on the outside. Okay, so then the sum of the exterior is going to equal to 3 times 120 degrees, which is 360. Again, all right, it will always be 360. It doesn't matter the shape. So if I ever ask you what's the sum of the exterior angles, you shouldn't really even have to calculate it. You should just know the answer is going to be 360. All right, that wraps up this lesson. And so hopefully, I know there was a lot to cover. We covered interior angles, some of the interior angles. We covered one interior angle, and we covered exterior angle. We covered a lot. And so hopefully we'll get to practice a lot more of this in the upcoming lessons. All right, let me know if you have any questions. But first, one last question for you. All right, hopefully you got that correct. And we'll see you next time.